All right. Uh, we are Team Health Tech Gurus, and we are going to be presenting our document parsing project using FHIR resources. And so I'm Casey, and followed with the help of Edgar and Shreyas and Vishal, we've created this project and excited to share this demo. So we're going to walk through the project background. And yeah, Vishal, do you want to go through that background?
Thank you, Casey. So just to give you a quick overview and background, as we all aware that patients' medical history and information is very critical for doctors and physicians to understand the health status of a patient so that they can develop a treatment plan. It is highly required that these records are available, properly recorded, availability should be secured and efficient, and finally, data should be able to transfer between different systems effectively. There are few challenges, and one of the challenge we would like to highlight here is that this process is like entering and extracting the data, which is like manual and very error prone. The data is manually downloaded through documents, and these documents oriented approach is highly considered a standard these days. Other important issue here is physicians need very specific data rather than going through the whole documentation. So as part of this document parsing solution, what team is currently working as proof of concept, we are trying to um, pass some text which should read through the provided PDFs. So that is our current status for the project, and I'll request our team members to go over the next step and share the details about the application. Thank you.
Thanks, Vishal. Yeah. So part of this project that Vishal was walking us through the background of, we've done some research on the academic and technical side. So we've looked into kind of the AI ethics of this. So when we're passing documents and retrieving documents and parsing data from those documents, it's crucial to map the data to the correct make sure the data is correct and correctly extracted, especially when hospitals and physician groups, they have different templates of documents. So there's a need to be 100% accurate in finding the data and mapping it to the correct the values. For example, some companies and facilities have been fined and have gotten in lawsuits, like United Healthcare, for either mislabeling data, or in this case for United Healthcare, their algorithm was used maliciously. And so we looked into especially for this case, we looked into how to make sure that we're mapping the data to the right patient. So especially for medications data, which we are focusing on in this project, is not mislabeling the medication, making sure that the patient gets the exact medication that they need. And so, yeah, and Edgar will kind of go into some of the technical side of this for our project.
Of course. Thank you, Casey. So for this project, we faced a couple of research problems related to health informatics that we had to solve. I would say that we had three main issues. The first one being, how do we get a FHIR server up and running for our application? While we did do a local installation of the Happy FHIR server during one of our labs, we did not get any indication as to how we can run this in some server that everyone can access, right? While there were various options for us to choose from in terms of cloud providers that might have their own specific implementations of the service, we just decided to go ahead and host the Happy file server ourselves using a serverless solution. Second problem we had to research was how do we use fire resources in a Python client, which is the technology that we decided to go with. During our labs, we did go through implementation of using these fire resources, but these were done in Java. So we had to adapt ourselves to a completely different library in order for us to be able to complete this project. And lastly, our final research topic that we had to go through was how do we map medication names directly to RX norm codes? As we learned during the lectures, RX norm is what is used as coding for medication. So we had to figure out a way for us to be able to turn plain text medication names into RX norm encoding numbers. Luckily for us, we did find a solution for this as well, as we researched and found that we can use an API in order for us to query this information and get the RX norm codes that we need.
Awesome. Thanks, Edgar, for walking us through that. And now, Shreyas will go through a demo of our project.
All right, thank you, Casey. Let me go ahead and share my screen. So I'm running a local deployment of our project right now, just for convenience of me showing the logs. But so I've ran it using Streamlit, and here's the front end. So I'm going to go ahead and browse a file, and I'm going to upload it. A sample file, sample one, I have it open over here, will look like this. So it's going to be a PDF that we kind of adapted to fit our code a little better, so that way we can prove that our solution works. So we have a bunch of these. We have 5 files to be particular. I can open all 5 if we need to, but they all more or less look like this. Here's sample 2. Here's sample 3. Here's sample 4. Here's sample 5. So for the sake of time, I will be uploading just a couple samples here. So I'm going to upload sample 1. And I'm going to check the logs. And we can see that that's the RX norm code that it saw. That's the medication resource it created. And here's the medication request resource it created. You can also see the patient resource that was created from the reference in the medication request JSON. So the ID of the patient we just created is 4. And I'm going to go ahead and check the happy server to make sure that that patient exists, that the medication request object exists, and everything is actually being created via the code. So I'm going to do a search on all the patients, and I'm going to look for patient 5. There's 1 and 4. So, sorry, I was looking for patient 4. I lied. So patient 4 exists in the happy server, just like our logs indicated. So that kind of proves that the JSON document that we just uploaded is what created the FHIR resource. We can go ahead and test the medication as well. It'll be medication 5, and you can see the time. So it's just when I just uploaded it. So we can show you medication request as well from here. I think we're looking for medication request. We're looking for medication 5. But we're looking for one that refers to medication 5 and patient 4. And so we see one that refers to medication 5 and patient 4. So this is the medication request that was created from that submission. So I can take you guys through the code real quick as well. I'm gonna keep it high level. But when we upload the PDF file, essentially it's gonna come over here. We're gonna open it up, and if a PDF file exists, we're gonna go ahead and convert it to a text file. Once we convert it to a text file, we're gonna save it, and then we're gonna reopen it. And we did this because we saw a complication with the PDF reading library adding a new line into the whole mix. So this was kind of our workaround to get it to work. Then we simply connect to the Fire server. We extract the data using regex, and then we create each object one by one. Before we create the medication object, we do call the RX norm code that Edgar was referring to. And once we created that object, we go ahead and send it to the FHIR server to actually save. But that's all I have in terms of demo. Thank you, Casey.
Awesome. Thanks, Shreyas. So yeah, also wanted to mention kind of the responsibilities on our team. So obviously we've all been contributing to the back end. Shreyas has been focused on the back end and front end. I've been kind of, full stack, Edgar full stack as well, and also a lot of the deployment side, Vishal back end and project management. So collectively we've been kind of, doing all different areas of this project. So I just wanted to briefly mention that. Also, to finalize, talking about future work. So right now we just have a basic, application that, accepts PDF documents, which are, fabricated in some way for the purpose of this project. And so, part of the, future is to be able to be agnostic to different PDF files. So like I was saying earlier, you have multiple facilities or hospitals and different insurance companies. They all have different types of documents, right? And so there's a need to, in the future of work would be to use machine learning, possibly, OCR, optical character recognition, NLP to extract data from different documents. So be able to run machine learning models to kind of find, different text containers and be able to kind of parse that data appropriately. Another big piece of this is, after you parse the data is, which we had originally, and we've spoke to this before, which was being able to chat with your the data on the document. So the physician can use this app and drop a file and be able to query the file, just a simple interface, kind of like a chat GPT interface where you're asking questions about the document. And so you say, hey, what is the patient's name? What is the, what is the last lab result for this patient? What's the medical history? And be able to type in these questions and just like kind of a chat GPT style, receive a response that's personalized, but it uses the data that was extracted and parsed. And so that's definitely one of the big items on our future of work. And I think that we will, one of the big things here is that we also, another big thing is to make sure it's HIPAA compliant. So on the parsing side, make sure that data is extracted accurately. So we don't want to mislabel things. We don't want to prescribe the wrong medication or map the wrong medication to the wrong patient, etc. So there's a big need to kind of secure and make things accurate, and then adding the chat function. So yeah, that's part of future work, and yeah, so this is our demo and presentation, and for HealthTechGurus. Thank you so much.